Decoded.
Welcome to Book Decoded. Forget those dense reads gathering dust. Think of us as, well, your literary treasure hunters.
Yeah, digging out the coolest ideas, the surprising bits from today's big books.
Exactly. And today, we are diving headfirst into Eric Topol's Super Agers. Get ready, because this could flip how you think about getting older.
It's not just about, adding years. It's about the quality of those years, really supercharging them.
Let's decode some of these health span secrets. What really jumps out from Topol's work?
Well, it's this convergence he talks about. It's powerful. Life science. Think genomics, CRISPR, mRNA tech.
All the cutting-edge stuff.
Right, and that's colliding with infotech.
Yeah.
Especially AI. And he's not talking small changes.
No.
No, he suggests this could actually fundamentally reset our expectations for human health span.
Okay, health span. Let's unpack that. It's the key phrase, isn't it?
It is. It's about living vibrantly, energetically, dodging those big diseases.
Heart disease, cancer, neurodegenerative stuff, the things we associate with aging.
Precisely. And Topol makes this fascinating link. He points to our immune system.
As the central command.
Kind of, yeah. A common mechanistic underpinning, as he puts it, for a lot of these age-related problems.
And these diseases, they don't just appear overnight, do they?
Not at all. It takes decades. Atherosclerosis, clogged arteries, early cancer stages, the brain changes leading to Alzheimer's or Parkinson's.
It's a slow burn.
Exactly. And that long time frame, Topol says, that gives us a real window, a big opportunity for prevention.
And inflammation is a key player in that slow burn, driven by the immune system.
You got it. It's often setting the stage year after year.
So it's like we need to keep our immune system finely tuned. Not too much inflammation, not too little.
That's the idea. And the science for that fine-tuning is moving fast.
But there's a catch, right? Topol mentions inequality.
A huge catch, yes. Health inequities. If these breakthroughs are only for the wealthy, well, the gap just widens.
The U.S. healthcare system doesn't exactly help there.
No, it's a barrier. Think about gene editing for sickle cell. Amazing stuff.
Right.
Or those GLP-1 drugs for weight.
We'll definitely get more into those. They're transformative.
Totally. But will they reach everyone who needs them? That's the worry.
He does mention some positive steps, like mental health apps, AI diagnosis in underserved areas.
Well, sure, good. Crucial, even. But Topol's clear. We need a much bigger effort to make these things accessible to everyone, democratize them.
Okay, let's pivot. Something fundamental. Diet.
Yeah, yes. Diet. So many books, right? Tens of thousands.
It's wild, yet the book says the evidence for one single best diet is, well, thin.
Surprisingly thin. And the idea that one size fits all, probably wrong.
And it's not just our individual choices, is it? He talks about big food.
Oh, yeah. Their influence.
Yeah.
And specifically, ultra-processed foods, UPFs.
He doesn't mince words about UPFs, calls them alien, unnatural substances. Basically not even food.
It's quite a description. And when you look at what's in them, the additives, artificial sweeteners, emulsifiers, hydrogenated oils.
It's a long list of industrial ingredients.
A very long list. And the data, it's concerning. Randomized trials show people eating UPFs gain more weight compared to unprocessed diets.
And it's not just weight, is it? The health links are pretty scary.
They really are. Fatty liver disease, many cancers, sleep problems, IBD, depression, dementia.
Wow. And that stat, what was it, over 4 servings a day?
A 62% increase in all-cause mortality, dying from any cause.
62%. That's staggering. So UPFs, engineered stuff, linked directly to a much higher risk of dying early.
It really hammers home how important it is to be mindful of what we eat.
Okay.
What about protein?
Right. Protein. Important, but too much might be bad, especially certain animal proteins.
Yes, Topol flags leucine-rich animal proteins, potential links to artery hardening, inflammation.
And the high protein push to fight muscle loss as we age, that's not totally figured out yet.
The optimal approach, especially with age, is still a bit unclear. Adequate protein seems reasonable, up to maybe 1.2 grams per kilogram of body weight, but excessive amounts need caution.
Okay. And fats. Sounds like quality over quantity.
Definitely. The type of fat matters most. Keto diets, for instance.
Super high fat, low carb, they get results for weight loss sometimes, but
they're linked to higher cholesterol, maybe cardiovascular risks, brain fog, even fatty liver disease in some cases.
And wasn't there a study showing keto dieters actually ate more calories than people on a low-fat, plant-based diet?
Yes, exactly. Challenging some assumptions there. And some animal research even hints high-fat diets could affect offspring health. It's complex.
What about when we eat? Meal timing.
Our digestion likes routine. But
Yeah.
the studies on time restriction or calorie restriction for weight loss kind of mixed results still.
Some hint that eating earlier might be better, like finishing by mid-afternoon.
Some trials suggest benefits for weight and metabolic markers with that early time-restricted eating, yeah. It's like
Yeah.
7 a.m. to 3 p.m. But it's not definitive for everyone.
And using AI for truly personalized diets, still early days.
Very early. Our bodies change, our physiology isn't static. It's a tough challenge for AI right now.
Okay, let's switch gears. Exercise. We know this is huge.
Oh, absolutely massive. The data is just,
Yeah.
wow. That big study, over 650,000 people.
Oh, walking one.
Yeah. Brisk walking, 450 minutes a week. That's like an hour a day, 6 days a week, roughly. Linked to living 4.5 years longer.
4.5 years just from walking.
It's incredible. And the benefits hit every major organ system. Lower heart risk, cancer risk, all-cause mortality down 31% with more activity, plus better sleep.
And it's not just cardio, right? Strength training is crucial.
Vital. Topol stresses regular resistance work. 4 or 5 times a week, maybe 20, 30 minutes.
I loved that quote. If I'm going to be old, I'd rather be strong and old.
Makes total sense. And those XA scans he mentioned.
Right. Bone density, muscle mass, fat mass. For like $50, $75, why aren't we all getting those?
Good question. Seems like really valuable info that's underused. Briefly, he also touches on environmental factors like pesticides.
Linked to various disease risks. Worth being mindful of exposure.
For sure. But let's get to those GLP-1 drugs we mentioned, a real game changer for weight.
These are the ones making headlines. Ozempic, Wegovy.
Those types, yes.
Mm.
The weight loss can be remarkable, often more than gastric bypass surgery.
How do they work? It's like turning down appetite.
Sort of.
Yeah.
They create fullness before you even eat much and slow down stomach emptying so you stay full longer. It's acting on the brain, too.
The gut-brain axis.
Exactly. Hypothalamus, brainstem. It dulls cravings not just for food, but potentially alcohol, tobacco, maybe even gambling.
Wow. And people tend to choose healthier foods on them.
Studies suggest that, yeah, more vegetables, fish. And they improve insulin sensitivity, glucose control, tackling metabolic syndrome.
Which is that cluster of risks: high blood pressure, blood sugar, cholesterol.
Right. And interestingly, the highest death risk in people with metabolic syndrome isn't just in the obese category, but also normal weight and overweight individuals.
So it's not just about being very overweight.
No. And these drugs show heart benefits too, about a 20% reduction in major events in high-risk people. And that happens before massive weight loss, likely due to reducing inflammation.
The potential seems huge. Alcohol reduction, maybe fertility help for PCOS, substance abuse, autoimmune, even anti-aging.
The potential applications are being explored widely. It shows how many pathways these hormones influence.
It really highlights the need for effective treatments, especially with type 2 diabetes having so many drug classes already.
Absolutely. And this connects to tackling cardiovascular disease more broadly. Heart attacks are still a huge issue.
Topol mentions life's essential 8.
Yeah, the checklist. Healthy diet, activity, no nicotine, good sleep, healthy weight, lipids, glucose, blood pressure. Key for preventing atherosclerosis.
And genetics plays a role too, right? Polygenic risk scores.
Yes, these scores can flag risk even if you seem healthy and have no family history. Some health systems are starting to use them.
And there's progress in lowering triglycerides and using anti-inflammatory drugs.
Big progress with RNA-interfering drugs for triglycerides. And yes, drugs like colchicine. There's now an FDA-approved low-dose version called Lodoco, specifically for cardiovascular inflammation, based on multiple trials showing reduced heart attacks and strokes.
Even detecting things like atrial fibrillation is getting smarter with AI in watches.
Right. Combining risk scores, inflammation markers, maybe GLP-1s. It's a multi-pronged approach to prediction and prevention.
Okay, let's talk cancer. Cases are rising globally.
They are. And Topol critiques the current one-size-fits-all screening model. Age-based screening for breast, colon, etc.
Low detection rates for early stages, high costs.
Yeah. And even new screening trials often rely heavily on age, sometimes lacking diversity. The key is catching cancer really early at the microscopic stage.
And treatment is getting more personalized. CAR-T therapy, personalized vaccines.
Exactly. CAR-T is like training your immune cells to be targeted cancer hunters. Neoantigen vaccines are tailored to your specific tumor. He calls it quintessential individualized medical intervention.
Amazing results in some cancers like glioblastoma.
Remarkable. And many combinations of immunotherapies are being developed. It's a rapidly evolving field.
What about diet and cancer risk? It seems complex.
Very complex. Animal studies show some links, like with high fructose corn syrup, but human trials are mixed. Still, certain foods seem protective.
Like broccoli, tomatoes, legumes, berries, garlic, the usual healthy suspects.
Generally, yes. Foods rich in compounds like isothiocyanates, lycopenes, fiber, antioxidants, allicin.
And for specific cancers like prostate, maybe using risk schools instead of just age for screening could be better.
That's the suggestion. Target screening and prevention trials, like with finasteride, more precisely. Think about HPV vaccination for cervical cancer or Hep B for liver cancer. Targeted prevention works.
Makes sense. Let's shift to neurodegenerative diseases, Alzheimer's, Parkinson's.
Key hallmarks there are misfolded proteins, inflammation again, brain cell death, synapse problems. And our brain structure does change significantly with age.
Especially after 40, apparently. White matter, gray matter decrease.
Cerebrospinal fluid increases, yeah. And many Alzheimer's drugs targeting that beta amyloid protein have, well, failed.
Aduhelm was controversial, right? Approved
time.
against expert advice.
Very controversial. Safety concerns, too. But there's some preliminary hope in repurposing other drugs or using non-invasive brain stimulation.
But the real breakthrough for Alzheimer's might be prevention.
That's where the focus is shifting. Identifying high-risk people early, maybe using blood tests like C-reactive protein for inflammation, and using AI to create personalized prevention plans.
And getting treatments into the brain is tough. Nanoparticles.
Crucial technology. Nanoparticles are being engineered to deliver gene editing tools like CRISPR or mRNA to the brain and other organs much more effectively.
For Alzheimer's, PKU, other conditions?
Being explored in animal models, yes. And CRISPR itself is already showing curative potential for genetic diseases like sickle cell anemia. There are even pills being developed now.
In vivo gene editing genes right inside the body is the next frontier.
Absolutely. Using different types of nanoparticles, gold ones, synthetic ones, even engineered exosomes to target specific tissues like the brain, spleen, muscle. It's a delivery revolution.
Which also impacts autoimmune diseases, right? Like lupus, MS, rheumatoid arthritis.
Exactly. Prevention has been tough despite many treatments. But again, AI analyzing genomics, biomarkers, health records, it's helping identify high-risk groups for prevention.
And restoring immune tolerance without side effects.
Yes.
That's the holy grail.
It is. It's complex, involves different tolerance mechanisms, but we're seeing progress. Engineered T cells targeting CD19 have shown amazing results in lupus. Treg cells targeting specific autoantigens have halted disease in animal models.
Identifying specific genes like TLR7 in lupus or specific immune cells helps too.
Definitely advances understanding. And this ties into vaccines too.
Modern vaccines have been incredibly successful. COVID, RSV.
Because of rational, structure-based design. Manipulating proteins to get the right immune response, like the RSV antibody for newborns Beyfortus. Single-dose protection.
And the idea that some diseases we didn't think were infectious might be. Like MS, linked to Epstein-Barr virus.
That's a huge link. EDV is the most common cause of MS. It's also linked to some cancers like Burkitt's lymphoma.
So vaccines targeting EBV are in development.
They are, aiming to block its entry into B cells, potentially preventing MS and those related cancers. It's a very exciting prospect.
And underlying so much of this, AI again.
AI is everywhere in medicine now, speeding up drug discovery, finding new antibiotics like allicin, helping design drugs based on structure.
Improving diagnosis too. Retina scans predicting heart attacks.
Yes, or analyzing DNA methylation patterns for aging clocks or cancer diagnosis. Reading images better than humans sometimes for cancer detection. Metagenomics sequencing everything in a sample could rapidly ID pathogens, but it's not widely used yet.
Even combining personalized mRNA vaccines with immunotherapy for melanoma, AI helps design those.
It plays a role in identifying the targets, yes. The personalization is key.
And we can't forget mental health and all this health span talk.
Absolutely critical. Chronic stress actually impacts cancer progression, metastasis. Mental well-being causally affects healthy aging.
And digital tools are making mental health care more accessible.
Yeah, digital CBT via apps can be as effective as in-person therapy, potentially. Much more practical, lower cost. AI chatbots are emerging too.
Plus simple things, green spaces, music, they help too.
They definitely have positive impacts. So looking at the big picture.
Life expectancy in the U.S. has kind of stalled, even dipped.
It has. So acting on known genetic risks is vital. But the deeper goal is understanding the fundamental biology of aging itself.
Cellular senescence, zombie cells, stem cell exhaustion, communication breakdown between cells, protein problems, mitochondria dysfunction, autophagy.
All those hallmarks of aging. And things like early tobacco exposure, major surgery, social stress can accelerate biological aging.
What about those anti-aging interventions we hear about? Young blood transfusions.
No good evidence for young blood, and there are risks. But research into senolytics drugs to clear those senescent cells is ongoing. Other strategies,
Like studying longevity drugs in pets. The dog aging project.
could give us clues, yes. Investment in anti-aging companies is booming, driven by real science. But there's also some irrational exuberance, maybe.
So, can we actually reverse biological age yet?
The only thing really well validated in humans for resetting biological age markers is exercise. It releases beneficial compounds called exerkins.
So, exercise again.
Always comes back to movement.
Yeah.
The ultimate goal really is to slow the aging process itself, allow more of us to become welderly.
Strong and old, vibrant contributors for longer.
Exactly.
Wow, what an incredible journey through the landscape of health span, all guided by super agers. It really feels like we're at a tipping point.
Yeah, the convergence of tech and biology. It's offering unprecedented opportunities.
Not just to live longer, but to live healthier, more vital years. From food choices and movement basics to gene editing and AI, it's a lot.
The potential is definitely there.
We really hope this exploration sparked your curiosity, maybe gave you some food for thought, perhaps some actionable ideas. What part stood out most to you? Is there something you're keen to look into more?
Lots to think about.
For sure. Thanks so much for tuning in to Book Decoded. Until our next literary adventure, keep learning and stay curious.